You can think of the ability to hold onto the voltage when the switch is turned off is related to memory, right? You need it to hold a value, and you might want this. You got to think of an application why you might actually want this, where you use the switch to turn something on, and then when you keep the switch open, that is from close to open, it remains on, so it holds on to the memory which it had when the switch was closed. So this is the circuit for sample and hold, and I explain the working in a bit. We have a switch. This goes to the non-inverting input. And then we feed back the inverting input. So V out is fed to negative, V minus. And the key is to have a capacitor as shown. Okay, so this is how it looks when the switch is open, and then clearly when you close. Let me just do it this way. I just need to redraw the circuit. So let's say it's the same circuit, nothing changes. Okay, so why I'm drawing two circuits is because let's say that here in this first step, you actually close this. Okay, so it's closed and held closed. That's my A. And B here it is opened. Okay, now the question is, what's going to happen? What does the capacitor do, and how is this going to work? So for A, when you close the switch, what's going to happen is, say this is V in, this V in would be here V in, right? So when the switch is closed, we see that V plus is V in, right? Because the switch is closed. And so the voltage at plus should be the input voltage. But we know that V minus is V plus. That's the Opamp assumption. And that's why we have V minus. Well, V minus is connected to V out. So from all these three, we see that V in is V out. Okay, so this is what they call a follower. That is, the input follows the output. Okay, so nothing is new here. We've already seen this circuit before. Now, when switch is open or opened, what happens is the act of closing the switch charges the capacitor. So when this is closed, the capacitor is capacitor is charged. Okay, and the charge is V in, right? Because it's this part is going to have V in when it was closed. So this is charged to V in. And so what will happen is when the switch is open, you'll see that V out, the output voltage will still be V in. Let's say V out as a function of time would be V in when T was closed. Okay, so here T is greater than T closed. What it's saying is that when you open it, you still have a voltage of V in across the positive end, which means that V out will also be V in, because the V plus is V minus, all these calculations. So this part is the part which says that it holds the voltage. And that's why it's called sample and hold. It's able to hold the voltage. For that, what you want to do is, there are some capacitors which will hold on to the charge. If normally if you have a capacitor and you just charge it and then you unplug it, they leak the charge and the charge is gone. So some capacitors are leaky capacitors, some capacitors are non-leaky. And what you want to do is you want to use a polystyrene or polypropylene. Polystyrene or polypropylene capacitors as they so I would say use as they leak very little charge. So that's what you'll use. Okay, so one more circuit and we'll stop. Okay, this is use of Opamp as a comparator. You have two inputs. You want to compare one input with the other. You can use a capacitor, sorry, Opamp to do that. Okay, so for any circuit which involves some logic, like you want to make a decision based on this is greater than that, then you will use a comparator. So this is the last one, 9th one. In this configuration, I'm going to show the Opamp is used in open loop configuration. There's no feedback. So V in, V ref, and then V out. Okay, now op-amps are not stable when they are open loop. Okay, when you have open loop like this one where V out is not fed back to negative or positive, you see that the output voltage will just saturate. By saturate, I mean it'll take the maximum value possible. So V out saturates. You know, we know that. Let me write the expression first. So V out equals V sat if V in is greater than V ref, is minus V sat if V in is less than V ref. Okay, now the question is, what would be the saturation voltage? Now, we've seen that V out is AV, V plus minus V negative. So this is saying that an AV is, it approaches infinity, which means that it says that for a very small difference between V plus and V minus, V out will be infinity. Now, that's not the case. This is how, so V out will go to infinity for small diff in V plus and V minus. Okay, now this does not happen in the real world because you just cannot get an infinite output voltage. What happens in reality is that if you remember, amplifier has a supply voltage, right? It has two LEDs which are for the voltage supply, which are actually in one of my earlier notes. Okay, so if you see the amplifier, there is a V plus, sorry, not this one, V minus and V plus. This is the supply voltage. Okay, and I'll show you the spec sheet how to find the supply voltage. This is typically 15 volts. Okay, that's the voltage you need to supply to the op-amp. It's an active circuit, it requires supply voltage. What you see is for the comparator, the V out will typically be 15 minus 1.5, 13.6 if V in is greater than V ref. In a Y 1.4, it looks somewhat like a drop in a LED where the drop in a LED is about 0.7, or it would be minus 13.6. So it'll be minus 15 plus 1.4, which will be minus 13.6 if V in is less than Vref. Okay, so it saturates to either 13.6 or minus 13.6. It doesn't go to infinity.